Now coming to the potential transformers, just like your CTs, where burden is one such factor which affects the performance of a CT. Don't get confused with the burden. Burden is nothing but the loading on the secondary side of the transformer. Similarly, for potential transformers also, as already said, potential transformers they do employ. They are just very similar like your conventional transformers, power transformers. The major difference is that the transformation ratio will be very high, which means that the primary side windings will be many in number, whereas the secondary side we will be having very low number of turns. So a potential transformer generally is employed to reduce the magnitude of a voltage signal such that it can be measured properly. Normally we do employ three different types of transformers. One is the conventional electromagnetic potential transformers, and CVT, capacitive voltage transformers, we do employ, and the latest one is coupling capacitor voltage transformers. They are sometimes called as CPT also, capacitive potential transformers. So electromagnetic potential transformers, they give us very perfect voltage. They will reproduce the reduced voltage perfectly. But what happens is that beyond a certain level of voltage, as we go on with the as we go on with the operating voltage of the circuits, for higher magnitudes of voltage, this is not economical. And one more thing is that the burden which they face, it is going to affect the output of your transformer, instrument transformer. So that's fine. From 72 kV, I'll take the round figure as 100 kV and above. We do have now 1200 kV operation also. Up to 1200 kV, we do employ normally CVTs. The CVT is just like, let us suppose if you do have a voltage which is to be measured. So here this is your measuring device. So instead of, it is just like a potential divider already existing, already reducing your value, and then you will be having a transformer. So this is your capacitive voltage transformer, and the modern modification is that we do have a coupling capacitor voltage transformer. So at higher voltage, these are employed normally. They are very cheap, and also they require less amount of size also. And the biggest problem is that they are not much affected by the burden on the secondary side load. Now, coming to the signal distortion and CVTs, even though CVTs are widely employed for higher voltage, the problem is that on the secondary side, which transducer you are going to employ, and sometimes the nature of the connected burden also, that is also going to affect the distortion of the signal. So that's fine. To overcome the disturbance which is created by the transducers and also due to burdens, certain modifications are to be done in your algorithm such that these can be compensated. Okay. Next, moving on to protection circuits. Normally, whenever we are measuring anything, we do experience surges also in the power systems. So during the time of measurement, we are supposed to protect our circuits. So CTs, basically what they do is nothing but CTs or PTs, they will just reduce the magnitude. If it is a very high value of current also, they will just reduce the magnitude and give it to you. But sometimes, let us suppose if I take a 200:1 CT, where it will reduce any current of 200 amperes to 1 ampere. Now what I should do now? Let us suppose I do have some 2000 volts to 1 volt. This is my PT. So normally my operating voltage is something around 2500 volts. So automatically 25 kV. So when I employ this transformer, the output will be somewhere around 1.25, I think, right? 12.5 volts. So this I'll measure with my normal device. So this job of this transformer is just to reduce the magnitude. Let us suppose if I get 2.5 MV or 25 MV. What will happen if the job of a transformer is that it will just reduce it by this transformation ratio. So what I'll be getting is I'll be getting 1250 volts for the second case. Transformer doesn't know whether it is a good value or a bad value. It just reduces the magnitudes. That's it. So your job is to protect your circuit against any surges. So that's fine. What we do is nothing but we do employ the surge protection circuits. They will protect your circuit from the surges. So normally the high voltage they are employed. They are protected by capacitors. And normally we do employ isolating transformers also. You know, an isolating transformer is just a transformer with just 1:1 transformation ratio. Why we do employ is nothing but to provide isolation to the secondary side equipment. So whatever the equipment which we do have, we will connect it to here, and the major transmission line that it will be connected here. So its job is not to reduce the voltage but just to provide an electrical isolation between the two circuits. So surge protection circuits normally employ capacitors and isolating transformers. Let us suppose if you do have electronic circuits, your voltage is already reduced and it is converted into DC or something like that. So for lower magnitudes we can employ Zener diodes. You might have heard about the working of a Zener diode. It acts as a voltage regulator, right? So Zener diodes can be used to protect electronic circuits against surges. Now, the other measures what we do generally take is we convert the secondary current measurements, whatever the parameters, into low level voltage signals. So whatever the currents which we have got on the secondary side of your CTs, they'll be converted into voltage signals with the help of I to V converters. So why? Because for the CTs, burden is the biggest problem. For PTs, it is not a big problem. So generally what we do is nothing but we do convert this I to V by means of suitable current burden, connected burden, or we will employ an I to V converter or an amplifier arrangement. Normally this I to V converter, they generally employ careful screening techniques, and they are arranged in separate modules which are far away from the digital signal processing of hardwares. So this is a representation of your surge protection circuit. If you carefully see, you do have this surge capacitors here. These are the surge capacitors which do protect your, see, this is your isolating transformer. If you see, this is isolating transformer which provides you an electrical isolation. So the data which you are getting from your CT and VT, it may consist of surges. So that's why what you are doing is nothing but you are employing surge capacitors and you are employing isolating transformers here, and after that it will be transferred to filters. We will see filters in the next lecture. Okay, so that's it from my side. So digital relays, basically they do have three major subcomponents, subsystems. The first one is signal conditioning subsystem, where analog signal is processed. And next is conversion subsystem, where analog signal is converted to digital signal. And finally, a digital processing relay subsystem, where the digital relay is processed. Okay, so I hope that now you are able to sketch the block diagram of digital relay and also list the components of digital relay. And I hope that you are now able to describe the working of the sensing circuits, in particular the transducers, and you are able to sketch the surge protection circuits. Okay, so the questions, practice questions, do at home. So we have completed the lecture. Go through this one, sketch a digital relay and list its components, and in particular the signal conditioning subsystem which we are concentrating on. And also describe the operation of transducers which are employed in signal conditioning system. Okay, so that's it from my side. This is for your additional learning, and we'll meet in the next video lecture where we discuss about LP filters and analog multiplexer. Thank you.